In this video, we will learn how to solve an exponential equation where we cannot rewrite both sides to have the same base. But before I do that, I've got to introduce logarithms. So x is greater than 0, that part right there. The base on the logarithm is greater than 0, and b cannot equal 1. So log base a of x equals y if and only if you can rewrite this, the b there, not an a, if you can rewrite this as b to the y equal x. This is logarithmic form, this is exponential form. They're equal. Logarithms and exponentials are inverses of each other. And so we went b to the y equal x. B to the y equal x. Now we might have y equals ln of x. I'm going to define both of these in just a minute. Ln, the base is always e. And we'll talk about e some more later on as well. So if I rewrote this in exponential form, if and only if e to the y equal x. Exponential form, logarithmic form. And I believe the majority of your classes will use ln, the natural log. Y equals log of x. If you do not see a base, this is the base, whatever number's down here, if you don't see a number down there, it's understood to be base 10. Base 10. That's logarithmic form. Let's practice writing it in exponential form. That would be 10 to the y equal x. Now the natural log, as I said earlier, always has the base e. Okay? E is about 2.7 and it keeps going on forever. It's an irrational number. So if you don't see it, it's understood to be an e. That's the only thing it will ever be. And let's rewrite it. If and only if e to the y equals x. Let me tell you what we're learning to do with this. You're going to have present value, future value problems where the variable is in the exponent. And you're going to use these methods to solve for that variable that's in the exponent. Okay, there's several properties of logs, but I'm just going to cover two right now. If you have ln a to the x, you can bring this x down in front and multiply. That's x ln of a. Okay, now if I write that in common log form, log base a of x, you can bring this variable here down in front and multiply it. See, this is your variable that you want to solve for is going to be up here, and you can't solve for it. So luckily we have this property where we can bring it down front, and it's on the same level as everything else, and you can solve for it. All right, let's look at some formulas. Okay, compound interest is this formula, and this formula is for continuous compounding. So A is your accumulation amount, and that's also known as your future value. Your P is your present value. It's what you invest in. That's the amount of money you put in the bank. This is your R is the interest rate in decimal form. N, this is number of times interest is calculated per year. So if it said it's calculated quarterly, that would be n equal 4. If it said monthly, it'd be n equal 12. And t is time in years. So if it was in there, let's say for 6 months, you do not want to enter it in terms of months. You want to enter it in terms of years, so you'd put 1/2 or 0.5. All right, let's look at what is E. Okay, I'm going to define it for you. So let's say you had the formula 1 plus 1 over n to the n. And that looks a little bit like the interest formulas. And let's let n be 1. So plug a 1 in for n. You get 1 plus 1 to the 1. That gives you 2. If you let n be 2, plug it in. You get 2.25. If you let n be 10, it would give you 2.593742. If I let n be 100, you'd think this would get larger and larger and larger, but it doesn't. This gives you 2.70481. If you let n be 1,000, sorry, let's do 10,000, you get 2.718145. So what is E? If you take the limit as n goes to infinity of 1 plus 1 over n to the n, I'm rounding 2.72. Let me get my calculator out for a second. E is 2.718281828. So I've just rounded to 2.72 just for informational purposes. This never gets to 2.8, okay? So that's how you define E, okay? Oops. E is approximately 2.718281828, but it keeps on going, guys. But that's where E comes from. All right, let me see what's next. Oh, effective rate. Just note this formula. If in your finance class they want to find the effective rate, that's what it is. R is interest rate, and M, I should have used N, but M is the number of times it's calculated per year. M times per year. And the effective rate, what that is, it's the simple interest rate, I equals PRT, that would produce the same accumulated amount in 1 year as the nominal rate compounded M times per year. All right, so just store that in your mind that you've got that formula in case you ever need it. I don't think you have any group work problems using it. All right, steps to solve exponential equation when bases are not the same. You're going to take the ln or log of both sides, okay? I'm always going to take the ln, and then you're going to use your property of logs, the one we went over on page 1, I think it was on page 1, and then you're going to solve for your variable. In the next video, we will do examples.